Section 9.4, the tangent ratio. Okay, so our objective for this lesson is to use the tangent ratio, solve real-life problems involving the tangent ratio. Okay, so first we have to figure out what this is all going on. This is actually an introduction to what in mathematics we call trigonometry. Trigonometry is actually broken down into, if you break the word down, trigonometry. Anometry means the measure of, measure or study of, and trig is triangles. So really, anytime you are doing something with a triangle, measuring something with a triangle, using a triangle to help you solve something, you're really doing trigonometry. Okay? And the tangent ratio is a very important concept in trigonometry. And where it comes from is it comes from our idea from this last section. It comes from our idea of similar right triangles. So if I have a right triangle, and let's say this right triangle has a 30-degree angle right here. Okay? Hey, and I have another right triangle. I don't know, let's say a bigger one. Right triangle, but it also has a 30-degree angle right here. We can be accurate in saying that these two angles are similar using angle-angle similarity. They both have a 90 and they both have a 30. So they are similar using angle-angle similarity. Well, if they're similar, then we know their sides are in proportion, which means their ratios are equal, the ratio of the sides. So here, if we label, let's call this small one A, B, C, and this big one X, Y, Z. Okay, and let's look at the sides in comparison to this 30-degree angle. Okay, let's look at the side opposite this 30-degree angle. So this side would be the one opposite the 30-degree angle, and this side would be the one that's adjacent to it. It's right next to this 30-degree angle right here. And if we look at this side that's opposite this 30-degree angle, and this one that's adjacent this 30-degree angle. Again, this could be any size triangle as long as it has a 30-degree angle in it. Okay? We know that the sides are in proportion. So if I put this side over this side, it'll be the same as this one over this one. So let's go ahead and let's give these some letters. Let's call this lowercase c because it's across from uppercase C. Let's call this side lowercase b because it's across from lowercase b. Okay. Let's call this one lowercase y because it's across from angle y, and this lowercase z. Okay. So if we set up our proportion here, and we take this 30-degree angle, I'm just going to go opposite, which is c over opposite z, and then adjacent b over adjacent y. We can do a little bit of mathematical magic. I can do means extremes, take the c times the y, and the b times the z. Okay. And then I can take both sides, and I don't know, let's take both sides and divide them by b, and take both sides and divide them by y. Okay, so it's a lot of variables here, but if you know this b divides with this b, this y divides by this y, and what I'm left with, excuse me, sorry, over here is c over b equals z over y. And if you notice, c was the opposite on this side, b was the adjacent, so we have the opposite, this one over the adjacent, and then here we have the opposite over adjacent. But remember, this could be any sized triangle. As long as it has a 30-degree angle in it, the ratio of the opposite to the adjacent is going to be the same. We did opposite over adjacent is going to be the same. This is what we call the tangent of that angle. The tangent of 30 degrees. Okay? Would be equal to, and this is how we'd write it, TAN, that's short for tangent, of 30 degrees. Note, this is not a multiply. This is not a multiply in between that tangent and the 30. Okay, basically it's us knowing that if I have a 30-degree angle, the ratio of the opposite to the adjacent is always going to be the exact same number. The opposite to the adjacent is always going to be the exact same number. And so back before calculators, what they did is they figured out this number. They figured out this ratio. If I had a 90-degree triangle, a right triangle with a 30-degree angle, they measured the opposite side and the adjacent side and divided it and wrote that number down. And then they did a 31-degree angle and then a 32-degree angle and then got those numbers because they know that that number is going to be the same no matter what size triangle you have. The division of the opposite over the adjacent will always be the same. And before calculators, what they did is they wrote them down in in actually a math table, this standard mathematical table, okay? And there's going to be a lot more numbers on this than what we know what to do with yet. But here, for like say these are our natural trigonometric functions for a 30-degree angle right here. 30-degree angle, the tangent of a 30-degree angle is going to be 0.57735, approximately. Okay, that's the approximate ratio of a 30-degree angle. Okay, and if I wanted a 31-degree angle, it was going to be 0.60866, and I could do any angle. Okay, 35-degree angle, we could have a really small angle. What about a 14-degree angle? The ratio is always going to be the same. Okay, so what that gives us is the ratio. Okay, now that we have a calculator, we actually have a tangent button in our calculator. So the tangent button, if you notice right here, is right there, tangent. But one thing to make sure you know is angles can be measured in both radians and degrees. Okay, so angles can be measured in both radians and degrees. We don't know radians yet, so make sure under mode right here, mode, the third down, make sure you're in degree mode. Make sure degree is the one that's blackened. Okay, if not, you arrow down, arrow over, hit enter on degree. Okay, now to get out of mode, you have to go second mode, which is quit. Now it goes back. So the tangent of a 30-degree angle, meaning the ratio of the opposite side to the adjacent side of a 30-degree angle will always be 0.57735, which if you remember, that was actually what the table had. 0.57735, you can read that really tiny right in there. Okay, but we don't need the table now that we have a calculator. The table has been pre-programmed into your calculator. So if I want the ratio of the side opposite a 30-degree angle to the side adjacent a 30-degree angle, okay? And again, this works for any degree of angle. I could find the ratio of a 50-degree angle, tangent of 50 degrees. If I have a 50-degree angle, the ratio of the opposite side to the adjacent side would be 0.1917. Okay, so that is how we define the tangent ratio. So here, the tangent ratio. And again, I have a triangle with an acute angle A. Okay, then the tangent of that angle, written as tan A, is defined as follows: the length of the opposite side, which would be BC, over the length of the adjacent side. And adjacent means side right by it. Okay, so we have the leg opposite the angle and the leg adjacent to the angle. So what we can do is we can, you'll see the use for this, okay, later on in this section, okay, but for right now we're just going to practice setting up that ratio. So if we want to find the tangent of angle A and the tangent of angle B, again, notice how I say that. I don't say tan A, tan B. It's the tangent of A, the tangent of angle B. Write each answer as a fraction as a decimal rounded to 4 places. So if I want the tangent of angle A, so we look at where angle A is. Okay, and I'm going to use some different colors here. So angle A is right here. First of all, this side's the hypotenuse. It's always the hypotenuse. But I want to find the tangent of angle A. I need the length of the leg opposite angle A. So if I go opposite angle A, opposite's going to be right over here. So this one's opposite of angle A. So that'd be 15. Over, so this other leg must be the one that's adjacent we say ADJ, adjacent to angle A, which is 36. So the tangent of angle A would be 15 over 36. So we can simplify that fraction. 15 over 36 is equal to 5 over 12. And then we want our approximate, which I already did, 0.4166. 0.416 to 4 decimal places, so 4167 if we go 4 decimal places. So the tangent of angle A is equal to 5 over 12, which is approximately 0.4167. Okay, now I'm going to switch colors. Let's go blue. So now we want the tangent of angle B. And the reason I switch colors, angle B is right here. My opposite side is now different. The opposite for angle B is over here, so this is now the opposite of angle B. And this one here is now the adjacent of angle B. So the opposite is 36 over the adjacent, which is 15. Simplify 36 over 15, that's going to give me 12 over 5. So 12 over 5, or we can, if you're not sure it's 12 over 5, 12 over 5, which is exactly actually 2.4. So I don't have to round that one. That's exactly 2.4. No rounding involved. Okay. All right, so this is just helping us find the tangents of certain numbers. Basically what we're doing is we're coming up with the table value here, meaning there's some angle whose tangent is 0.4167. So we can actually find that angle, 0.4167 in our table, and we'll actually look, it looks like 0.42 is 23 degrees, 0.40 is 22 degrees. So we're somewhere in between 22 and 23, so 22 point something along those lines. And we'll look at how to do that later on in a later section. Okay. But here in example 2, we're going to use this tangent ratio to help us find a missing side. I know an angle, I know a side. We want to find this missing side here. I can't use the Pythagorean theorem because I don't know the hypotenuse. Here's my hypotenuse right here. Right here's my hypotenuse. I don't know the hypotenuse, but I do know the opposite. If this is the angle that I know, I do know here's the opposite side and here's the adjacent. Okay? And I do know that the tangent of this angle, the tangent of a 25-degree angle, will be equal to the opposite side, which is 12, over the adjacent side, which is x. So the tangent of 25 is just a number. We can get that approximate number with our calculator. The tangent of 25 degrees. Again, mode, make sure you're in degree mode. It shouldn't switch on you mid-problem, but if you're not using your own calculator, you want to make sure you check that. Again, the tangent of 25 degrees is just this decimal, 0.466307. So it's just a number. This thing right here, I'm going to grab a pencil. This guy right here is just a number. Okay, so now to solve this, I'm going to put this number over 1. So then I have a fraction equals a fraction, and I'm going to means extremes. So I'm going to take this number times x. I'm not putting the approximate in because we don't want to round it now because then we could have rounding errors later. So I'm going to take the tangent of 25 degrees times x. That equals 12 times 1. So then now to get x by itself, again, this is just a number. I'm going to have to divide both sides by that number, which is, I'm going to write it the tangent of 25 degrees. Okay, so these now divide out, so x is equal to 12 divided by the tangent of 25. They tell us to round it to the nearest tenth, so I'm going to put an approximate sign in, and I'm actually going to round. I'm going to take 12 and divide it by the tangent of 25 degrees. Okay, so 12 divided by the tangent of 25 degrees, enter. To the nearest tenth, 25.7. So this missing side is 25.7. And now that we know this missing side, we know both legs, we could find the hypotenuse. It doesn't ask us to, but we could. Okay. All right, here an extra example 2. Okay, you are going to have practice like this. Make sure you know how to do this problem for the skill check. Hint, 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 hint. Okay. It says to use a special right triangle to find the tangent of 30 degrees, meaning it wants the exact tangent. Okay. So one thing is a 30-degree angle is part of our special triangle. If this one's 30, this one's 60. And we know the sides have a special relationship. This side is the short leg. This one is the long one. This one is the hypotenuse. Okay? So we know that these relate to each other in a certain way. Okay, so I'm going to make this just some random 30, 60, 90 triangle whose, let's say, short leg is, I don't know, should we have it be 3? Okay. So then the hypotenuse, if you remember, the hypotenuse is twice the short leg, so the hypotenuse would be 6. And then the long leg would be 3 square root 3. Again, I just made up this 3. I just picked a number. Because I know the ratio, no matter what number I pick, the ratio is going to be the same. Okay, so I just picked a number, any old number I wanted. Okay, so keep that in mind. I just picked a number. You could have picked 5, you could have picked 12, you could have picked 400 if you wanted to make your life difficult. Okay, but I just picked a number, I just picked at random 3. Okay, so I know that here's the angle we're looking at, this 30-degree angle. So the tangent of 30 degrees is going to be equal to the opposite side. There's opposite, which is 3, over the adjacent. Here's the adjacent. The adjacent is 3, the square root of 3. Okay. Well, this is 3 times 1. So this 3 divided by 3 is 1. So I end up with 1 divided by root 3. We don't like square root 3's in our denominator, so I'm going to multiply numerator and denominator by square root 3. 1 times square root 3 is square root 3. Square root 3 times square root 3 is square root 9. Square root 9 is just 3, so I end up getting the square root of 3 over 3. So the tangent of 30 degrees is the square root of 3 over 3. It will always be. Do you notice how the 3 didn't even matter because I ended up canceling? So like I said, again, you could have picked 5, you could have picked 12, you could have picked negative 42. It always would have worked. Okay. So, and actually we can get an approximation here. They want exact. So here's the exact tangent of 30 degrees. But if I do an approximation, square root of 3, arrow over, divided by 3, it's approximately 0.57735. If I do the tangent of 30 degrees, I get 0.57735. Okay, so here's the exact tangent. This is the exact one. This is the approximate. So your calculator cannot give you the exact. Okay, and we'll learn different methods. If you take pre-calc with me, we'll learn all the different methods of finding the exact tangent of certain angles. For right now, we're just doing approximate. All right, okay, we have one more thing to talk about, and that's angle of elevation. Okay, the angle of elevation is the angle created when when you look up or something is thrown up, meaning up in the air, okay? So how an angle of elevation works is if something, I don't know, let's say I've got something right here, okay, and it's looking up at something up here, okay? Let's put y up here. So here we have x, here we have y. So basically, we have this line of sight looking up like this. The angle of elevation is what angle does this make with the horizontal. So the angle of elevation is always measured from the horizontal. Is always measured from the horizontal. So it would be measured from the straight left and right. So here's my horizontal. I'll draw it in dotted. The angle of elevation would be this angle here looking up. The angle of elevation is always going up. Hence, elevation means going up, like a balloon goes up. It elevates. Okay. All right. So how this can be used is angles of elevations are used a lot in like real life application type problems. So you are measuring the height of a tree. You stand 40 feet from the base of the tree. Okay, so we've got the ground. So I'm going to draw myself a nice big picture. Here's the ground. Okay. Here's my tree over here. There's my tree. I'm only going to draw half the tree. Okay. You are standing 40 feet from the base of the tree. So here's the base of the tree. We're standing over here. So here's you. Okay, and this distance here is 40 feet. The angle of elevation to the top of the tree. So if I'm looking from you to this top of this tree, what we end up making here is a right triangle, because this is 90 degrees, and this is a straight horizontal. The ground is horizontal, they don't tell me otherwise. This angle of elevation, this angle up, is 65 degrees. Okay. We want to find the height of the tree. We're trying to find this height h. Well, we know this angle 65 degrees. The side we're trying to find here is actually the opposite side from 65 degrees. The side we know is the adjacent, so we can set up a tangent ratio. The tangent of 65 degrees is equal to the opposite side, which is h, over the adjacent, which is 40. Okay. Again, I'm going to put this over 1 so I can do means extremes. Again, the tangent of 65 is just a number. Tangent 65 degrees. About 2.1. Okay, but I'm not going to put that number in yet because I don't want to do any rounding. So let's do means extremes. So I'm going to take the tangent of 65 degrees times 40 equals h times 1. Well, that's just h. So I just need to take the tangent of 65 degrees, close parentheses because I only want the tangent of 65, and then I want to multiply that times 40, which we get 85. It says the nearest foot, so if we're going to just one single foot, 86 feet. So the height of the tree is approximately 86 feet. Approximately 86 feet for the height of that tree. Okay. So here's one very useful way of finding the height of something very, very tall without having to climb it. I've talked a little bit about some projects we're going to be doing where we find the height of something very tall, and we're not climbing it. So keep that in mind when you're working on these tangent problems. How could this be used in a project type problem? Okay, so write your practice problems down. See me if you need help or if you're stuck or if there's part of this you don't quite get, and good luck.